Welcome back to the Deep Dive. Today we're going to tear apart some pretty dense technical specifications.
We are. We're looking at the infrastructure that really powers professional broadcasting.
And we're analyzing a specific piece of gear. It's the Thor Broadcast F-4SDI-B-3G-TXRX-RM.
Quite a name.
It is. And for you, the learner, our mission here is to figure out how professionals move these massive, uncompressed video files over huge distances.
Right, without it all just falling apart. There are some real technical breakthroughs in this one.
Okay, let's unpack this.
So, at its very core, what are we looking at? It's a fiber optic system, a transmitter, and a receiver.
Exactly. And it's built for SDI signals.
Serial digital interface. Yeah, that's the absolute backbone for anyone in pro video.
So if this is a kind of optical superhighway for those signals, I mean, how fast is it really running?
The speed is, well, it's a huge part of the story. It can handle uncompressed signals up to 3G-SDI.
Which is, what, about 3.0 gigabits per second?
That's it. Gold standard for high-end HD. But the speed isn't the only thing. It's the density.
Ah, right. That's the real operational shift here.
Yeah.
This thing can transport 4 separate channels of video.
And they're bidirectional.
Bidirectional. All over a single tiny strand of optical fiber.
That's wild. You're collapsing 4 physical systems into one.
That's the magic. And it's enabled by something called coarse wavelength division multiplexing, CWDM.
Okay, so break that down.
Think of it like assigning a different color of light to each of your 4 channels.
And then you just stack all those colors onto the same fiber.
You got it. Each color, each light wave, carries its own separate signal.
And the documents say that 4 channels is just the starting point. It can go up to 16 on one fiber.
Right, and if you really need to scale up, they mentioned DWDM systems,
Yeah.
dense wavelength division multiplexing.
Or is it up to 160 channels?
160 on a single fiber.
That sounds like an absolute configuration nightmare.
You'd think so, wouldn't you?
Here's where it gets really interesting.
It is, because the sources say this whole unit is plug and play. It requires, and I'm quoting, no configuration or management. That's the breakthrough. That saves the engineer's sanity.
It's built to be agnostic. It just doesn't care what you feed it.
It just automatically adjusts.
Yep. From a slow 1 megabit per second link all the way up to the full 3 gigabit 3G SDI. It even handles DVB ASI for, cable and satellite.
Okay, but if you're pushing those signals, say, 50 kilometers, which the specs say it can do,
Yeah, that's a long way.
how do you stop the data from just breaking down? Doesn't the timing get sloppy over that distance?
It absolutely does. That's called jitter. And that's why data integrity is so important here.
But what does it do about it?
Well, first, it passes all the ancillary data, like your embedded audio. But crucially, all the outputs are automatically reclocked.
Reclocked. It's like a reset for the signal.
Think of it like a signal conditioner. It takes that slightly degraded signal that's traveled 50 kilometers and just regenerates a perfectly clean, sharp signal before it hits the next device.
And that's all standard, right out of the box, housed in a normal 1RU rack mount unit.
And that standardization is key. For you, the learner, this is important. The internal modules are industry standard.
So you're not locked into one company's ecosystem.
Exactly. The source even names compatibility with systems like Python, so you can mix and match. It protects your investment.
So this is for live broadcast, ENG, government, scientific research.
Anywhere you need uncompressed, high-quality data to just leap across a massive distance without any fuss.
So what does this all mean?
Fundamentally, it's about making something incredibly complex feel simple and reliable.
Right. You're taking these high-speed video signals, shooting them up to 50 kilometers down a single fiber.
And you're doing it without a complex setup because it's plug and play.
Yeah.
And you're guaranteeing the quality at the other end because of the automatic reclocking.
It's maximum capability, designed for maximum operational simplicity.
Indeed. And we focus mostly on the 4-channel model, but I want to leave you with a final thought. Think about that 160-channel DWDM system they mentioned. The ability to push that much data, that many uncompressed streams, over the same single fiber, it just raises a huge question.
Which is?
What kind of content, what future applications will demand that incredible level of density? What makes 160 channels the new broadcast standard?